So welcome to my Windows Server 2016 Top 10 Features. Now I'm currently recording this around a technical preview for timeframe. So the code is not complete, but I don't expect any major new features to be added to the operating system. They may make tweaks and some additional minor capabilities, but to all intents and purposes it's pretty much functional complete. So I'm going to go through what I think are the 10 features the greatest portion of the population will be able to benefit from. But this is not exhaustive. There are obviously other features I just don't have time to cover in what is only a top 10. Very quickly, who am I? I've been doing this stuff for a long time now. I still run the ntfaq.com, and a lot of the things I'm going to talk about throughout this, I have facts that go into more detail on. So if you have more questions about the containers, I've got facts on that talks through doing that. Storage spaces direct, there's facts on that. So take a look at that if you want to go into more detail on some of these technologies. I've wrote a bunch of books. I'm currently writing, mastering Windows Server 2016 HyperV, and I'm trying to get into this Twitter thing. And what I'm going to start doing is sort of ask me anything, and ways that I can better interact with people. So I'll announce that on the Twitter. So if you want to go and add NTFAQ guy to that, then that'd be awesome. So this is not really about surprise. So what are my top 10? So these are the technologies I want to dive into. These are what I'm going to cover at some level. The depth will vary depending on how sort of cool and interesting I think it is. But these really make up my top 10. And a lot of this is about creating an amazing fabric, an amazing cloud operating system platform that you can use on premises. But maybe if you have hosting providers, they can use in their hosting facilities. And of course, Azure is going to use some of these facilities as well. So you're going to have this very much hybrid solution. So I have a choice. I can say, hey, I'm writing this cool new application. I'm writing it using the Azure Resource Manager model. I'm going to deploy it on-prem. Or do you know what? I'm going to deploy it at my hosting partner. Or I'm going to host it in Azure. Or I'm going to host it on-prem and then burst to the cloud when I get a super busy time. I have virtual machines I create. I'm going to be able to easily move them around. So all of these features really just help Windows Server 2016 be that amazing platform. So configuration levels. You'll probably be familiar with this if you played with Windows Server 2012, which is where this configuration levels designation really took off. In 2008, though, we had Server Core. And this was an installation time choice. I could have what was at the time a full server install, or I could pick Server Core. Server Core is a subset of elements of the operating system. There was no graphical interface, there were no management tools, I would manage it remotely. And that suffered in 2008 because it was very hard to manage remotely. They addressed this with 2008 R2, and in 2012 it became a level I could modify while I had a deployment. I could actually go into Server Manager or PowerShell, and I can add and remove levels of the user interface. I could say, well, remove Explorer, but leave the management tools. Or remove the management tools as well and go to Server Core. And the naming changed as well. Server Core became the default. Server Core became what you really should use, and then the other option was just Server with a GUI. And if you wanted to write an application that could get gold certified, it had to be able to run without the GUI. The goal is my server shouldn't have people logging on interactively and doing stuff. I want them managing remotely from my Windows 10 client. Now the reason I want this smaller operating system is really a number of reasons. Less footprint, so smaller disk size. Less code means less attack surface, less patching required. Less patching required means less reboots. And also, as the smaller we get, likely the faster we can deploy it. And now we have, in 2016, we have Windows Server with desktop experience. Now these are install time options. I now cannot change this once I've deployed. So I pick this when I'm installing the OS. Windows Server with desktop experience. So it has that Server Core platform, it has the management tools, it has the graphical shell, it has desktop experience. So that really should tell you something about what this is aimed at. This is aimed at remote desktop session hosts. where I'm going to have users coming in to get a published desktop or published applications, and I want a full experience like I was using a client operating system. My other option is Windows Server Core. That's what we're used to, the server core. And then I have another option now, Nano Server. Nano Server is this new, completely refactored version of the operating system. It still has the key things like performance counters, event logs, the kernel, but it really has stripped away a lot of the other stuff that's not required for key use cases. Now, those key use cases are, this is really designed for my new born in the cloud applications. And when we say born in the cloud applications, we're really thinking about web applications, microservices, web services. I'm thinking about the cloud platform, HyperV servers, scale out file servers. And the footprint is just crazy on this. 93% lower VHD size, 92% fewer critical bulletins, and 80% fewer reboots. So this is going to be our target platform when we can meet those scenarios, and this will expand in the future. I think my understanding of this is that Nano Server will really be the 20-year path for Windows Server. So as we saw Server Core initially, not many people adopted it, not a lot of stuff would run on it. Nano Server, initially, it has a focus on a couple of scenarios, but you're going to see that grow. This will become the foundation. So I want this for the less maintenance, deploy super fast, but where is it? If I go and look at a Windows Server setup, I can see my Windows Server install, which again is Server Core, and I can see my Windows Server brackets desktop experience. That's the one they don't want you to use. That's the one that really I'm thinking remote desktop session host. So where's Nano? Nano's not there. So where is Nano? So I'm going to jump over to a 2016 box. And I'm going to look in the file system. And actually let me open up another folder as well. So this is the folder for the Windows Server 2016 media. You'll notice there's a nice little Nano Server folder in there. There I can see the Wim file that makes up Nano Server. But Nano Server on its own is so small because it has no extra roles, no extra features. Instead, there are packages that I have to add into my image. So this is another reason why there's no just standard install option. For Nano Server, I'm going to create my own custom Nano image. I'm going to select the packages which are language neutral. And you'll notice I actually have language specific additional packages that go with those language neutral packages. I'm going to add those into my Nano Server image and then deploy it to a box. And they have instructions for how to deploy it. Basically, I have to copy these two files over to a server, which is exactly what I've done over here. And then what we do is we can use PowerShell. So I've got PowerShell over here that's going to let me go and create a Nano Server image. Now I'm going to go through this super fast. Basically, I'm creating a credential that I'm going to pass into my Nano Server image that can be the secure password. So I give it a source for where my media is for 2016. I specify a temporary folder where it can create the stuff it's going to create. I give it a path where I want to create my new VHD because I'm going to create this as a VM, but I can do this to physical as well. I'm going to give it a computer name. And I want to add some stuff. I want to add in guest drivers because it's going to be a HyperV VM. I want to add the storage capabilities, Windows Defender and HyperV. And I want to enable remote management. So I set flags, parameters for each thing I want. I'm going to set my administrator password. And I'm going to make it join the domain. I don't have to do anything else. If the host I'm running this on is a member of the domain, I can just add that flag and it will automatically create the required accounts. Now I've done this demo before. So I'm going to say reuse the domain node because I've already got something called Nano VM2. And I run that. Now what this is going to do is start copying the stuff over into that base folder. Just copying things in. And it's actually going to take the packages it needs, move things around, add them into a temporary WIM file, build them into the VHD. So this will take a little while to run. This is not great hardware I'm running this on. These are just some local disks in the machine. So it's pulling that over, it's mixing things around. This may take a couple of minutes. So through the sort of magic of editing, we'll make this happen much, much faster. So now I can see it's got into adding the packages. And it's going to do this for each of those things I specified. The storage, the Defender, the compute, the guest drivers. It's going to open up that management port so I can manage it through Server Manager. So I can manage it through PowerShell. So you can see now it's adding language packs. For the features, we added the language neutral, binary. Now it's adding in the language specific elements. Now it added an unattend, and that's done. Now the other thing I do here, I'm not going into any detail at all, but by default it's Pacific Standard Time. And the way it does all its configuration is via an unattend answer file. So what I do in this tiny little bit of code here I've selected is I mount it, and I add an XML node element that sets the time zone to central. And again, this is all written up on the ntfact.com. So that's done. And now what I'm left with is my shiny new Nano Server VM. So remember, this is essentially, generalized is the wrong word, but it's not been specialized. It's not ran that unattend answer file yet. So I'm just going to cut this, paste it into my temporary Nano folder. I'll then look at my second Nano VM. I'll add that new disk into it. And then let's actually connect to it and we'll start it. So this is the first time it's ever booted. This is going through the specialization phase. Because remember, I've modified the unattend, it's having to read all that content in, and I'm done. So that's not just a super fast boot, that's a super fast specialize and is now useful. I can now do stuff on this. I can log in with an administrator account, because remember, I joined it to the domain. But this is what I get. This is Nano Server. There is no local interface. There is no command prompt. There is no PowerShell prompt. I manage this remotely. I have limited emergency capabilities to fix my networking, fix my firewall. But this is designed to be cattle. We're moving away where our OS instances are pets. We don't care for them. We don't fix them when they're sick. If they're sick, we shoot them, and we stand up another one. And you saw how quickly I could stand up one of these things. We don't take time to manage this thing in terms of resolving it. Why is it misbehaving? Why won't it boot? Bang, it's dead. We create a new one in its place. But I still have super rich management capabilities of this. For example, if I go to my server manager, this is still Windows Server. If I go and look at my all servers, you can actually see I have another Nano VM. I'd already added this in the past and then deleted it. But I can see it's connected. It's actually going already. It was the same credential. I can see what's on that Nano. So I'm managing it through Server Manager. I can manage it through PowerShell. I can invoke commands to it just like I would do any other remote server. Now there are some cooler options as well. So I've logged into Azure, the public Azure. You go, why on earth am I doing that? Because we have something called server management tools now. I already added my other Nano server. And what I can do here is I deploy a server management tools gateway to my on-premises location. What that does is it establishes a HTTPS-based connection out to Azure, which now lets Azure talk to the machines that I specify. In this case, I added my Nano server box. I have to give it a credential for that Nano server. And now I can manage that thing. What it's doing now is connecting. I can see its CPU, memory utilization, its network adapter information. I can go and manage its IP addresses, its local administrators. I can see event viewer. I can even have a PowerShell window to that machine. Now, this is not mandatory at all. As I already said, all the existing management tools you know and love are going to work with Nano Server. I can manage it remotely with PowerShell on premises, Server Manager, all my other tools. This is just another option. Let's go and look at my computer name. Is it host name? I always get this wrong. But I can go and look at environment variables, for example, and go and get information. I could go and get the processes. Easy way to do this. Now today, this is from Azure only. And it's very easy to add additional operating system instances that I can now manage. When I think about Microsoft Azure Stack and its consistency with Azure, I would be shocked if this functionality didn't find its way into Azure Stack as well for on-premises. But again, this is not stopping you at all. If you don't use this, don't use it. You don't need to. It's just another option and another way in which you can manage your servers. So that's Nano Server. Super slimline, very fast to deploy, less maintenance, less reboots. And this is really going to form the future of what we're going to be doing with Windows Server. Next is containers. When I think about today, deploying an application for us IT operations people can be problematic. Some app dev person goes and writes their fancy piece of code. They package it up, they give it to you, and they say deploy it. You deploy it, and it doesn't work. It errors, it says missing X, Y, and Z. So you have to get the developer, and they try and help. And they install a bunch of stuff, and it works. But that was painful. It was hard to deploy. I might have very, very complicated runbooks of every step I have to do to install it, to configure it, to get the dependencies up and running. Containers solves this. Containers lets me enable applications and their dependencies to be configured, documented within its own unit, its own sandbox. We call them containers. And I can have containers have dependencies on other containers. I could have a website that has a dependency on a container with IIS installed, that has a dependency on the Windows Server operating system. So I have these layers. These are super fast to deploy because they can share OS instances. Now they're isolated from one another at a user mode. So within the operating system we have the kernel mode, which is the super important bits, and then we have the user mode where applications generally run. So these containers, traditionally, they run with a user mode isolation. So they're very fast to deploy because I don't have to deploy a whole OS instance for every container. They're isolated, so I'm not worried about them interacting with each other's user mode space. And I can still use things like resource management. I can restrict the amount of CPU and memory and IOPS and network traffic. Containers we normally think of Linux. Now they've come to Windows. So Microsoft have created their own container technology. And I can manage that technology through either Docker or PowerShell. So I have a choice. If I'm a big Linux shop today and I'm used to Docker, I'm probably going to go to Docker path. If I'm more of a Windows guy, I'm used to PowerShell, I'm probably going to go the PowerShell path. But we have a choice. We pick how I want to manage these things, but underneath it's still the Microsoft container technology. Now I cannot run Linux applications. It's still running on the underlying OS of the container host, which is Windows. So today when I look at this, I can't run a Linux app just because it's a Linux Docker app and expect that to run on Windows. So to maybe make this a bit clearer, I think of this. And this is kind of a Docker example. I have an application which has a dependency on some libraries, some binaries, which has a dependency on the underlying host OS. And so on a single OS instance, that container host, I have my kernel, and I have the user mode space with different containers of binaries and libraries that can coexist because they're isolated from each other. I don't have the problem of maybe them clashing, which I would on a normal OS. And I have different containerized applications that use different sets of those binaries and libraries, all quite happily coexisting, using resource management, isolated, their own little sandbox. Essentially behind the scenes, there's like a union file system that takes the virtual file system from the app to the virtual file system of the binaries and libraries to the system of the container OS, and it merges them, it unions them together. So the container app just sees one file system, one set of processes. But there's some cool stuff going on behind the scenes to actually make that happen. Now this is great, but it is user mode isolation. So in Windows Server 2016, I actually have two types of container. I have Windows containers, which is what I just showed. Then we have HyperV containers. And what you'll probably notice is, it's the same container technology. I create my container app the same way. It's a deployment choice. I don't have to do anything different from my containerized app. It's when I deploy it, I pick, do I want a Windows container or do I want a HyperV container? All a HyperV container is, it's an automatically created super low management virtual machine. I don't even see this thing. I don't pick names. It's automatically created. It uses its own base image kernel, and then it runs the Windows container essentially inside it. Why do I want this? Isolation. Windows containers give me user mode isolation, and that's going to be fine for on-premises, for many environments. But if I'm in a multi-tenant environment, if maybe it's a very sensitive application, I don't want to risk some attack on the kernel that would then expose my app to other tenants. Hyper-V containers, the isolation's at a kernel level. Each containerized app is running in its own OS image. So I have complete isolation even at the kernel. Now obviously, this takes a little bit longer to deploy. It uses up some more resources, but I pick. What do I want? Windows or Hyper-V? And I can change my mind. I might initially deploy it as a Windows container. It's like, do you know what? I need a better level of isolation. I'll redeploy it as a Hyper-V container. And when we deploy this, we think about using Nano Server as that base image. Well, you saw how quickly I can deploy those. So yes, it deploys a bit slower because I'm not deploying to an existing OS, but it's not that it's slow. It's still pretty quick. So this is a great technology as a new way to think about deploying applications in my environment. It solves all those challenges of, well, how do I deploy this thing? How do I move this thing? Where's this big run book of instructions that I have to follow? The developer creates the containerized app for me. They put it up in a library, and they're going to be standardized libraries. And I just pull it down and I deploy it. So completely, it's going to change the way we think about deploying apps. So I wanted to very quickly show just some of the things containers will do. So what I created was a super simple website. And it basically is just going to show, let's see if I can open this with iExplore, Superman beating up Batman. As that is totally what would happen in any real scenario. All these things about a battle is completely pointless. Superman's just going to kick his butt. So anyway, I have a folder with that index file and that picture. And I have a Docker file if I wanted to use Docker instead of PowerShell management. If I open that up, just quickly take a look at that Docker file. I can just see I specify the base image that I'm building on. And then I want to add in these files into my Docker container, into that path. But I'm going to focus on the PowerShell management, but I have the Docker commands as well if I want to do it with Docker. Very simple with Docker. I'm going to pull down an image from the Docker repository that's got IIS installed on it. I would then build based on my Docker file and then run it. I mean, that's it. When I build it, it adds in those images I specified, and I'd be up and running with a new website based on the IIS image it pulled down. But instead, what I'm going to do here is firstly to install containers. Microsoft has a very easy script I run. I've already done that, basically. And if I have a look, I have two images, a Nano Server and a Windows Server Core. If I wanted to add it, I could run find container images. This would find them, and I could pull one down. But right now, I'm going to create a brand new one. And I'm going to actually base it on Windows Server Core. So this is creating a new container that's dependent on Windows Server Core. If I look at the containers I now have, I have an IIS demo that's turned off. I'm going to start that container, because once I start it, I'll now be able to interact with it. Now, actually what I want to do is, remember on my local machine, I have this IIS demo folder. And I want to be able to interact with that. So one of the great features we have from PowerShell is I'm going to add a container shared folder. So my source path and a destination path in the container. In my case, they're the same. So now I'll be able to copy stuff between them. So I'm going to start it up again. And what I'm going to do is run some PowerShell commands in the container. I'm going to install the web server. So that's finished. Now I want to go ahead and delete out of that container its default IIS start page. And now I just want to copy in my own customized index and Superman beating up Batman picture. Now I could enter a PS session, so I can just use regular PowerShell to start snooping around and look inside that thing. Now what's going to happen is that container has its own networking stack, its own independent IP address, etc. Now it uses a virtual switch on the host, which in my case is just using NAT, so it doesn't have a valid IP address outside. So this is the IP address of that container. So what I'm going to do is I'm going to add a mapping between its port 80 and my port 80 on the host. So I've done that. So what should now happen is, if I go to the IP address of my container host, I should see that web page. So if I type in that IP address, there it is. Superman looking at is easily beaten up Batman. If I was to stop the container, so it's going through and actually stopping that. This always seems to take a little, I think it caches it for a while, but eventually watch that if I do control refresh, this should now time out. Yep, there we go. So it's showing I'm accessing. So how quick was that to stand up that container? All of the time was creating a container with IIS, but normally I would actually have a middle tier. I would have actually created a separate container with IIS and then created my custom website off of that IIS container. I just did it this way to speed up the demonstration. Now I could go and clean up that NAT rule and delete my container. So that's just a quick demo showing how easy these containers are actually to use. And in this case, this was a Windows container. But I could have just as easily deployed it as a HyperV container by adding a switch to my deployment. Number 3, storage. Now I'm going to focus on really 2 technologies. But there are others. I mean, there's a bunch of different improvements around storage. There's cool stuff around centralized scale-out file server quality of service. I can now have centralized policies that can be shared for all VHDs in a VM, a group of VMs, a service, a tenant. And it will fairly distribute the resource between all of those. There's improvements to deduplication. It's now multi-threaded, so it's going to optimize things quicker. It works with bigger servers, works with Nano Server, works with mixed clusters. I can use deduplicated volumes now for saving of data. ReFS, now really being pushed as the forefront file system. Going to work great with Hyper-V and VHDX files. But I want to talk about Storage Spaces Direct and Storage Replica. Now I don't want to talk about licensing, but licensing is changing. Windows Server 2016 moves to per core licensing, and whereas we're used to right now standard and data center are the same, that's not actually the case now for 2016. There are features in data center that are not in standard. Now, don't panic. The instant reaction to this is, oh no, I'm using standard. I'm doing this stuff. Microsoft's going to make me buy data center. That's not the case. Any features that are in standard today will continue to be in standard in 2016. What's happening is some of the brand new enterprise technologies, they will only be in data center. So you're not losing anything. It's just to gain some of the brand new enterprise-centric technologies like the storage, like the new networking, virtualization stack, I'm going to need data center. So I'm going to talk about these. So firstly, storage spaces direct. Essentially what this lets me do is if I have a cluster and I have nodes in that cluster with direct attached storage, just a bunch of disks, maybe it's an external enclosure that's connected to each box. Currently, I can't really use that storage. 2016, I can. 2016 is going to let me aggregate all of that storage together using SMB3 for the replication. It will then be seen as a cluster shared volume in that cluster. So then in a hyper-converged model, I would just then use that storage to host my HyperV VMs, for example. Or I could offer that CSV out as a scale-out file server to remote Hyper-V servers that would access it via SMB3. But the big deal here is I'm using direct attached storage for the nodes in my cluster, and then making it usable as a cluster resource. It will replicate data between fault domains, which are nodes. So any piece of data I have is going to be replicated 3 times. So 3 nodes will have a copy of that piece of data. They're going to use a mix of technologies. Again, it's going to support using your SSDs for super fast caching. It's going to use mix of mirroring and parity to give me the high performance, but also higher capacity. So it's going to mix all those different things together to give me the best experience. Probably easiest to just see this. So I'm going to go through a very quick demonstration of this. So what I have here, in this environment, I have 4 virtual machines. If I actually show you my Hyper-V, I have 4 nodes. Each node has 2 data disks. So all the same. So what I'm going to do is the first thing I have to do is enable cluster storage spaces direct. So it's like, hey, I want to use this technology. I can then check, well, how many disks can I actually use with this technology? So it's waiting until the disks are claimed. It's going through this check to enable storage spaces direct. So I cannot mix this. I cannot mix storage spaces direct with clustered storage spaces where I have some shared enclosure connected to multiple nodes. I can't mix these. I pick one. So that finished. Let's have a look and see how many disks I have available to me. So I have 8, which is what we expect. So I'm just going to very quickly create a new storage pool using those disks, and then create a virtual disk on that. So I'm using the CSV FS ReFS, so it's leveraging ReFS for this, which lets me do that merging of parity-based storage spaces for bigger capacity, but also mirroring for the higher performance. Set file integrity. And don't worry about the exact commands. These are going to change. So what I'm going to do here is just define a couple of functions. Because what these let me do is see the disks. So here, so I've mixed all those together. And what I should see already, so I can see I have 4 enclosures, 1 for each node. And the disks I have are going to be spread over those 4 enclosures. So there we go. But what I now see on my file system is I have a CSV volume. There's nothing in it right now. So how do you really know that's what's happening? How do you know it's using all of those disks? So I have a performance monitor, and it's looking at the physical disks in each of the 4 nodes. Right now it's not doing anything. So I'm going to run a disk performance tool and create a test file on that cluster shared volume. Run. And sure enough, all 8 disks are going IOPS. They're all working. So what is this demonstrating? This is demonstrating I'm taking direct attached disks for nodes in my cluster. I've aggregated them together, replicating using SMB. It's shown up as a single CSV. I can then use that directly on the cluster. For example, storing my HyperV VMs in a hyperconverged scenario. Or I could now create a scan-out file server and offer that storage out to remote nodes. It's replicating the data. So I have 3 copies of my data. So I've got protection from disk failure. I have protection from node failure. And this is just a great new way that I can leverage that direct attached storage. If I'm now architecting a location, I don't have to think about buying a SAN anymore. I think, well, I can just add direct attached disks and leverage that. And that's becoming more and more popular when we look at these hyperconverged scenarios. And there we go, the test finished and it stopped doing the I/O on them. So that's demonstrating that storage space is direct, easily using my storage. The next technology is storage replica. So lots of storage stuff. I mean, this is one top 10 is storage, but an amazing amount of technology. Storage replica is block level replication between standalone boxes, between boxes in a cluster, between clusters. I can do synchronous or asynchronous, and again, it's using SMB. SMB for the replication traffic. It does cool stuff around preserving and making write ordering. And it's at the very, very bottom of the storage stack. I can think about storage replica, and then on top of that is volume manager. On top of that is BitLocker, then VolSnap, then the file systems, then file filters, then dedupe. This is under everything, which means it does not care about your workload. It does not care if it's BitLocker. It does not care if it's deduplication. It doesn't care if the file is locked. This is a block level replication technology. If it sits on a file system, storage replica is going to be able to replicate it. Now, synchronous is the preferred, but async is also an option. So I can think about maybe I have a stretched cluster and I don't have a storage fabric that can replicate today. Well, now I can. I have standalone boxes I want to do replication for. Now I can. So it just opens up a whole new set of scenarios. And it's just super cool. And again, so both storage spaces direct and storage replica, they're part of the data center SKU. Networking, and particularly network virtualization. Network virtualization's been in Windows Server for a while now. 2012 really kind of introduced it. 2012 R2 introduced a native gateway to let me connect virtual networks together, to connect them to the outside world, etc. And I always managed this with System Center Virtual Machine Manager. It used NVGRE as its encapsulation method. For Windows Server 2016, they've really taken Azure as inspiration. I'm not saying it's the same code. It's the inspiration for a brand new V2 of HyperV Network Virtualization. Now, the existing HyperV Network Virtualization V1 is still going to be there. It's going to continue to work. But all the investments are in this new HyperV Network Virtualization V2. And it really is re-architected. Now, I can still use NVGRE, but also now I can use VXLAN for encapsulation. So I have more options for the encapsulation of that traffic. There is a brand new network controller, part of Windows Server. And whereas before I required SCVMM for the control plane for network virtualization, now it's the network controller. It's in Windows Server 2016. There are new network function virtualizations. So think of like virtual network appliances, but there's going to be some in box. Gateways, firewall capabilities, load balancers. They're going to just be part of Windows Server 2016. So it's much broader software-defined networking support with the different types of encapsulation. That controller is going to give me various northbound and southbound management interfaces, so I can manage it using different technologies. It's going to be able to manage other types of network virtualization and network technology. But I don't have to use SCVMM. I can still use SCVMM if I want, and it's going to give me a great experience using service templates. But for my management plane, there are 3 planes to network virtualization: the management plane, the control plane, and the data plane. So the management plane can be Azure Stack. If I use Microsoft Azure Stack, that's the on-premises Azure consistent technology that uses its own management for network virtualization. Or I can use SCVMM and its service templates, or I can use PowerShell. And they've actually got a software-defined networking express set of script. SDN Express it's called. And this will basically do everything for me. It creates the little VMs I need for the various controllers, load balancers, and I'm up and running. But I have to pick one. I can't mix these. I can't start off using Azure Stack and then want to move to PowerShell or SCVMM. So the one you're going to use really is going to depend on your management philosophy in the organization. If you're using Azure Stack, then I'm going to use Azure Stack. But you pick one of these. But really what this solves is today organizations really struggle with VLANs. They struggle with the complexity. They struggle with the agility. It takes me a long time to create service tickets when I want to deploy a new app because I have to mess around with 20 different switches, top of rack switches, aggregation switches. There's a lot of work goes in there. It's very inflexible. It's very slow. It's limited. I think normally even the best VLAN infrastructure is going to max out at about 1,000 of them. Well, with network virtualization, it's all software-defined networking. I don't make changes on my physical hardware equipment. It's all done in software. Think of Azure. Azure onboards tens of thousands of tenants constantly. Do you think that would be possible if they were manually raising a service ticket and some guy with glasses, I'm not saying everyone in a data center wears glasses, but some guy with glasses was running around trying to move things around and reconfigure switches? It would never happen. Azure will be limited to 1,000 tenants because VLANs would max out at that. So this gives me huge flexibility, huge ability to respond, huge agility, huge scale. And I think as companies start to really embrace this, they're going to get much more flexibility and capability with all these virtualized functions with network virtualization. So number 5 is clustering. Clustering is built on an assumption that the clusters will be deployed on quality hardware that was well architected with great networking. And that's what used to be the case. There used to be a separate hardware compatibility list just for clustering. That's not the case so much these days. I'm one of these guilty people. We have these virtualization administrators now who very quickly cobble some stuff together and say, hey, there's my cluster. I'm going to run stuff on it. And what can happen is, because maybe things aren't as solid as we'd like them to be on the storage or networking front, you get these transitory failures. You get a blip. You get a blip in the network, and 2 nodes can't talk anymore. And what clustering would used to do is, oh my goodness, I can't talk. I'm going to drop out of the cluster because I've lost quorum, and all of my virtual machines, all of my services, someone else take them, someone else run them. Well, for a virtual machine, that can take quite a lot of time. If I throw up in a panic state and someone else has to restart my VMs, it might take 5 minutes to restart all those virtual machines, where it was a 5-second network blip or a 10-second network blip. Maybe my storage architecture is not that fantastic and I lost contact with my storage for a second, but that meant my VM blue screened. Nothing to do with the host, nothing to do with HyperV. I had a storage problem. But how that is surfaced is the VM crashed. And so Windows Server 2016 has done a lot of work around resiliency, about handling these transitory problems with storage and networking. There are other changes as well. Domain boundaries are gone. It now uses a self-created certificate for authentication between nodes in a cluster. So it's all done automatically. So what that means is I can have a cluster, sure, they're all in the same domain. That's what we're used to. I can have nodes in different domains. I can have a mix of member servers and workgroup machines. Machines that aren't even part of a domain now. So it really opens up a lot of new scenarios, particularly for those DBAs, those SQL guys. They love this. It's easier to get to 2016. It's going to be easier to get to new builds of Windows Server 2016. Today, if I move from 2012 to 2012 R2, I either needed a lot of spare hardware, or I had to take nodes out of the cluster, build a new cluster with the nodes I took out, migrate some resources, take out some more nodes, put them in the new cluster, migrate some more resources. I couldn't mix. 2012 R2 to 2016, I can do a true rolling upgrade. I still drop a node out the cluster just so I can rebuild it with 2016. Then I put it back in the same cluster. I can have a mix. 2016 and 2012 R2 nodes in the same cluster. The 2016s kind of act in an emulation mode. It's a mixed cluster. They pretend they've got 2012 R2 functionality. And then I drop out another node and upgrade it to 2016, put it back, and so on. Once all my nodes are running 2016, I flip a switch and I put it into a 2016 mode, and suddenly I get all the cool new functionality 2016 offers. So what are some of the other changes? To the cloud. Azure Storage can now be used as a witness. So we used to be able to have a disk witness, a disk that's accessible to all the nodes in the cluster, or a file share. And if I had a multi-site cluster, I would often use the file share, ideally at a third location. What if I don't have a third location? What if I have an environment where I don't have any shared storage? Now I can just use an Azure Storage account. So if I jump over to one of my clusters, and let's take a look at this one, you can see I'm using Cloud Witness. And all I have to do is specify the name of my Azure Storage account and a key. And what actually happens behind the scenes is it just creates a file in that storage account. So let's jump over back to my account. Let's go and look at my storage accounts. And what I'll see in this is a container. So I'll go to my blobs. Now we don't like to say anything is ever free, but I think this is free. And the reason it's free is when we see, so it can take the container MSFT Cloud Witness, it creates a whopping 0-byte file. It's pretty hard to get charged for a 0-byte file. Microsoft round things. I've never been able to get charged for this thing. Now, I'm not saying you would never get charged for this thing, but if you did get charged for this thing, I think you're looking for a cent. 1 cent for your witness. And again, I don't think you're ever going to even see that. So now I can just use Azure as my witness resource. Opens up a lot of new scenarios. What else? Compute and storage resiliency. So I talked about those challenges before. I talked about, well, look, if there's some blip in network communication and a node falls out the cluster, all of its VMs would get restarted on other nodes. So the outage caused by me moving the resources is going to be far greater than the outage caused just by the blip in the network. Likewise, if I have that blip in the storage connectivity, the VMs crashing and then having to restart is far greater than if I'd have just paused the virtual machine. So that's exactly what compute and storage resiliency does. If there is some blip, it does things to help it. So what I'm going to do is in one demo, I'm going to try and show both. So on my third node, I have 2 VMs. The first VM is using a cluster shared volume, which means it has to be part of the cluster to see that disk. So what's going to be emulated here is losing access to its storage, because I'm going to drop this node out of the cluster. VM4, well, VM4 is actually running on a scale-up file server, SMB3, so it will not lose connectivity to its storage. And the functionality of what we should see is this. So compute resiliency says, look, if I drop out of the cluster, give me a while. Don't make me lose my VM straight away. So by default, for 4 minutes, it will continue running its VM. So even though it dropped out the cluster, we're saying, look, let's give it a while. Let's make sure this isn't just transitory. So it will continue running. So we should see VM4 continue running. VM3 is going to lose access to its storage, but instead of crashing, it's going to stun. It's going to pause that virtual machine. So we should see this go into a sort of paused critical state. Now, I'm going to be looking at another node in the cluster. And on the other node in the cluster, we're going to be looking at a few different things. Firstly, the VMs will go in a funny state. I want to look at the various roles because they're going to go into an unmonitored state. And then the nodes themselves will see clustering. We'll say, hey, look, there's a challenge with this. So I've got this view, I'll be able to see all the different resources. So how can I emulate this problem? Well, I have this nice thing called the cluster service. If I stop this, it basically crashes the cluster. So I'm going to end this. So when I end this task, what I should see is VM4 keep running. VM3 will lose access to its storage because it's using a cluster shared volume. If it falls out of the cluster, it can no longer access that CSV. So it's going to lose its storage. So I end it. And straight away, see this is running, it's gone into a critical, and this will now pause. If I go and look at my other node, you can see the VMs have gone into an unmonitored. The node has gone into isolated. And what's going to happen is this one's going to a paused critical state. I think it's just not updating quickly enough. Now, once the cluster service restarts, there we go, pause critical. There we go. This encountered critical I/O, so it stunned it. So instead of letting it risk blue screen, it's like, do you know what? I'm just going to stun you. But VM4 has carried on running. So there's no interruption to it doing its job just because there's some transitory network problem. Now, within about a minute, cluster service will restart again. When cluster service restarts again, it will just join back in. So this is demonstrating two things. Compute resiliency. Hey, it's fallen out the cluster, but rather than make those VMs move around, it just keeps it running. Cluster service is starting. It will then, so it's already done it. It's back up. It's running. This will come out of paused critical. Once it feels confident that storage path is back, CSV takes a little bit longer. It's checking a few things, but then this will just go to running again. Now there is another feature as well. So there we go, it's running. Imagine I have that node that's in the cluster, out the cluster, in the cluster, out the cluster. I don't want that. So if a node ungracefully leaves the cluster 3 times an hour, any roles on it are drained gracefully, live migrated, and then it's quarantined. And quarantined for 2 hours. After 2 hours, it can rejoin. The assumption is someone's going to help it, fix it in that time, and it's good to go again. Now, I mentioned that 4 minutes previously. You can tweak it. You could make it shorter. You could make it longer. Obviously, the smaller you make that time, the less of a transitory issue I can tolerate. But if there's a real problem, I'm going to react quicker. The longer I make it, then I can accept a bigger transitory issue. But if there really is a problem, it's going to take me longer to react and really restart the services. So 4 minutes seems to be a very good mid-range number. So you put all of those things together, I have fantastic resiliency against network transitory problems, compute transitory problems, storage transitory problems. Number 6, HyperV. Tons of cool new features. Nested virtualization. Now this was required for containers. When I think about HyperV containers, where that container runs in a minimal zero management virtual machine, well, if my container host was a VM, I wouldn't be able to do HyperV containers. So nested virtualization lets me run a VM in a VM, but it's not restricted to that. I can actually just use this for regular, maybe training lab environments. So what does that look like? I have a virtual machine here, Sav Nest 01. Now there are a few requirements around this. I mustn't use dynamic memory. I have to enable max spoofing if I want the VM in the VM to be able to go and talk to the network. And I have to enable the VM hardware assisted virtualization capabilities to be projected through to the virtual machine running inside of me. Now, the good news is Microsoft actually have a script called Enable Nested VM, which you can download very easily. You just run this get hub user content, and it's in the Microsoft Docs, walks through this, and that does all the work for you. And it's very easy. If you just go and look at the code, you can see exactly what matters. So here, expose the virtualization extensions in the proc, make sure dynamic memory is not enabled. I want MAC address spoofing. I need a decent sized memory. I think it's 4 gigabytes or 8 gigabytes, but obviously how many VMs I want to run inside is going to dictate the amount of memory I need. But I can now run VMs in VMs. So I have my example here, not my Nano. I have my nested VM, so that's running on my hypervisor. I double click on that. I go and look inside this virtual machine. And this virtual machine, I've enabled the projection of the extensions. And then inside this, I've enabled HyperV and I have a VM running. So I have a VM in a VM. So now I have this ability, particularly useful for those HyperV containers. But there may be other scenarios as well. I can finally run VMs in VMs. I just have to project the virtualization capabilities of the processor into that VM. And that's just a PowerShell. It's a configuration on the VM processor configuration. There is a new HyperV VMCX binary format. If I looked at an older virtual machine, the configuration file was all stored in an XML file. This XML file is saying maybe I tried to change, I made problems with, if there was an unexpected power outage, maybe it got corrupted. So what's actually changing here is for the new VMs that are using the hardware generation 7, what I now have is a VMCX file. This is binary. I can't do anything with this. I can't manually edit this. It's more resilient against any kind of corruption from a power outage. I have a runtime state file. But it's changed the format of how it's actually storing those virtual machines. I have production checkpoints. We always say never, never, never use checkpoints in production. Because the way checkpoints worked is it would save the disk state, the memory, the device, the CPU state to disk. The OS inside of that VM had no idea this checkpoint was created. And if I suddenly then just applied it in a production environment, I might cause problems. Domain controllers had a huge issue with this before virtualization safe DCs in 2012. But now we have production checkpoints. And this is an option on a per VM basis. And what this does is this actually calls the VSS infrastructure in a Windows VM, so it flushes everything out to disk. For Linux, it does a file freeze operation. So now I get the same level of checkpoint, quality of data on disk, as if I actually performed a backup. So it doesn't have to save the memory and device state anymore. In fact, it doesn't. It just freezes the state of the disk after it's done that flushing out to disk. It questions the changes. It's just like taking a backup. And I can say, well, look, if I can't create a production checkpoint because it has to use the backup integration service to go and talk to the VM. If I can't do that for some reason, then take a standard checkpoint. I know it's not as good, but sure, I'll accept that. Or I can say, do you know what? I like the way checkpoints currently work. I want to freeze the state of memory. I want to save the state of device and processors. Maybe that's something to do with the testing I'm doing. Then I want standard checkpoints. But I have a choice. Production, application consistent like a backup flash to disk, or standard ones just save the memory and device state as well. I can do hot add remove of memory and NICs to generation 2 VMs. So this isn't dynamic memory, where memory is added or removed based on the working set of the OS. This is, I will add it in, I can pull it back out again. Now obviously the OS has to be willing to let memory be pulled back out. So let's have a look. I'll take one of my nodes here. I've got one network adapter and I have 2 gigs of memory. what I can do is to this virtual machine, this is not using dynamic memory, but it is going to let me change this. I'm going to give it 4 gigs of RAM. It's modified the resource. If I look back inside the VM, hey look, it's all happy. I've got 4 gigs of memory. Do you know, it's let me down. I'm not very happy with it anymore. I can actually take it away. Now think how hard it is for an OS to be able to just take memory out of it. So this requires Windows Server 2016, I think Windows 10. And this will work in the future with Linux when they have this sort of support. I took it out. Now there's a bug, I think, in Task Manager. If I close Task Manager and open it again, the memory's actually gone down. So whereas dynamic memory would only ever see the high watermark, I'm actually pulling memory out of this thing. Exactly the same for network adapters. Hey, this virtual machine, do you know, I suddenly have a need to connect it to another network. Let's add a new NIC. Go for it. And it sees it. And do you know what? I don't need it anymore. There's my NIC. Remove it. And it's gone. So very powerful ability now to hot add and remove both memory and NICs to virtual machines. When I think about managing a HyperV VM, I can manage it using WSMan. I can PowerShell to it, I can server manager to it. If I had some problem with network connectivity, maybe I use VM Connect. That gives me a direct console level session. PowerShell Direct is kind of a merging of them. It lets me get PowerShell access to a virtual machine even when maybe the networking isn't working inside it. Because VM Connect, while it will always work, I can't automate that. It's a graphical tool. So PowerShell Direct, I can just directly hook into a virtual machine. So let's jump back over to this environment. And let's close all this down for the time being. And I want to talk to a virtual machine. Now, I need a credential. So this is a credential that's going to be inside that VM. So this is not a bypass of security. I still need a valid credential within that virtual machine. So I'm going to set a domain admin that I can use within it. Once I've done that, I use my standard PowerShell. So I'm going to invoke a command. I'm going to use the credential I just created. But this time, I use VM name. So this is new. And what VM should we talk to? We'll take savnest01, our nested VM box. And then whatever code I actually want to run. So in this case, maybe you want to prove, well, am I really talking to that one? So I could say computer name. And there we go. So I'm using PowerShell not through the networking stack. I have to be on the host. So I'm on the host, and I'm talking to a VM on the host. I have to have a credential into that virtual machine. This is going to work with Windows Server 2016 and Windows 10 virtual machines. So it's a way to directly interact using PowerShell VMs. Linux now supports Secure Boot, so I can guarantee a secure handoff between the hardware and the operating system. There's a virtualized TPM now for Generation 2 virtual machines. Management improvements. I can now manage older hypervisors. And when I manage them, let's do a connector server. When I go and manage one of those older boxes, I can actually specify a different credential. I can now use things like credSSP. So I can hop, I have more flexibility in my management. So that's all cool. The biggest feature I think for Hyper-V is shielded VMs. And this can be a little hard to get your head around initially. So let's just look at this. Today, in a lot of virtual environments, there are lots of types of administrator who can access the assets of virtual machines. I could be a virtualization admin, a storage admin, a network admin, a backup admin, a domain admin. There's tons of admins. Now, if I'm an organization, including hosters, I need a way to secure virtual machines even from those administrators. And this is what shielded VMs is going to give me. Now you might say, I trust my admins, and that's important. In many ways, I need to trust my admins. But I need this protection in a virtual machine environment for a number of reasons. It could be a phishing attack. It could be stolen administrator credentials. It could be an insider attack. So I want protection even from these admins. And the shielded VMs provides protection for the data and state of a virtual machine against inspection, theft, even tampering when I have administrator privileges. Now this works for Generation 2 virtual machines because they give me the necessary secure boot, UEFI firmware, virtual TPM that I need to enact this technology. Now the host itself has got to be running Windows Server 2016, but the guest operating systems can be Windows Server 2012 or above. So that means I can take advantage of this even for my older workloads. And shortly after release, Linux is going to work with this as well. Now, to get this, I have a new Host Guardian service instance that's deployed in the environment. And this is going to be that repository for the keys required to run the shielded VMs from an authorized HyperV host that can prove they're healthy. And that's an important part here. They have to be able to prove their health. So how is this security possible? Now the first thing is I need to know the Hyper-V host has not been compromised before the required keys to access the shielded VMs are released from that host guardian service. Now this health of the host is measured in a process called attestation. And I can do that in one of two ways. Ideally, the Hyper-V host as a TPM 2.0. So using this, that TPM 2.0 can be used to guarantee the boot path that the Hyper-V host went through and that code integrity. So I know no bits of malware, rootkits, or unapproved software has found its way onto that server that could compromise my security. The TPM is used to secure the communication to and from the host guardian service attestation service. Now if I have a host that doesn't have a TPM2, which for most environments with older hardware will be the case, I can use an AD-based attestation. Now, the AD-based really just says, well, is the Hyper-V host in an AD group? And if it is, okay. So it gives me some level of protection, but it's not giving me protection from meddling with the binaries or abuse of the host administrator privileges that a sophisticated attacker could do. So I use one of those things to show my health. Once I've gone through that attestation, I get a health certificate from the Host Guardian Services Attestation Service. It authorizes the host now to get keys with that health certificate. The keys are encrypted during transmission and can only be decrypted from within a protected enclave that's also new to Windows 10 and 2016. I'll talk about that more in a second. Those keys can be used to decrypt the virtual TPM that's helping protect the shielded VM, which lets the VM access its BitLocker protected storage and start. So what that means is only if the host is authorized and healthy will it be able to get the required key to enable access to the VM, get access to the storage. But remember that VHD is still encrypted on disk. So even though I'm an administrator, I still can't get access to that. Now there's a lot of other cool stuff going on. You might wonder, well, if I'm an admin, I could probably get the key. I can't. Windows 10 and Windows Server 2016 has a virtual secure mode, VSM. This is used by a number of key OS components, including Credential Guard. And VSM is basically a secure execution environment where secrets and keys are maintained, as well as critical security processes which run as trustlets, which are very small trusted processes, in this secure virtualized partition. It's not a Hyper-V VM, it's just a small virtual safe protected by virtualization technologies like SLAT, IOMMU to protect against memory and DMA attacks. Not even the Windows kernel can get access to this thing. Only trustlets, these whitelisted processes that are Microsoft signed, are allowed to cross this bridge to access the VSM and do stuff. And that synthetic TPM for the shielded VMs is a virtual TPM trustlet. So it runs in that protected space. That's where the keys are. When the keys are sent encrypted, that's where they're decrypted. So when I put all of this together, I have the ability to create a shielded, protected virtual machine environment, even from any level administrator. So what do I get? I get BitLocker encrypted disks. My live migration traffic is encrypted. I have a hardened VM worker process, which means my state on disk, my runtime state file, my save state, my checkpoints, my HyperV replica, they're all encrypted. Existing Windows Server 2012 and above can be used, as I mentioned. I don't get any console access anymore, nor do I get any path that I may consider insecure, key value pairs, host exchange items, guest exchange services that let me do file copy operations. They're all blocked. So this gives me compliance for environments requiring machines to be encrypted and even higher levels of protection. So in a nutshell, shielded VMs, what does it give me? Protection from the admin. And not just protection from the admin, I think more importantly, protection from administrator privileges, however they were gotten. So if I'm on premises, if I'm a multi-tenant scenario, I can now guarantee, especially with the TPM 2.0 attestation, I can guarantee protection even from a host administrator. They will not be able to get those assets of a virtual machine. They won't be able to run them on other hosts. The VM will only run on those qualified Hyper-V hosts, and even an administrator can't get access. So this is an amazing leap, I think, for 2016 to help me guarantee very, very secure virtual environments, which a lot of organizations are calling out for. Remote desktop services, number 7. Huge thing here, OpenGL 4.4 and OpenCL 1.1 Remote FX support. Understanding the new Remote FX changes is best seen by actually witnessing an environment. So here I have a Hyper-V 2016 server. In that server, I have a GPU that I've enabled for use for Remote FX. Now, the first change is that when I assign this adapter to a virtual machine, it's now possible to actually assign it up to 1 GB of dedicated video memory, so I can give it more memory to use for those applications. Now previously, Remote FX would only work with DirectX applications. A huge change in 2016 is this now works with OpenGL 4.4 and OpenCL 1.1. So what this means is there's now pretty much all 3D applications are going to be accelerated by this virtual GPU. I can think about Adobe Photoshop, Blender, Maya. They're all going to now benefit. AutoCAD applications are great examples of this. So if I jump over to this virtual machine, if I was to go and look at its device manager, what I will see is for its display adapter, I have a Microsoft Remote FX graphics device. That's standard. If I was to launch DXDiag, I will see that I have a DirectX compatible graphics card. Again, no change here. But now I have OpenGL support. Now I have OpenCL. So there's different ways to try and demonstrate this. If I go to my C drive and go to test, I have a little GPU test application. I can set the various resolutions to this and run it. And it runs great. I have a weird donut shape with a fancy background. But it's very smooth. And what's happening here, remember, is the virtual GPU inside that virtual machine is performing the actual calculations on the GPU in the Hyper-V host. And then it's sending this using Remote Desktop Protocol. So there's other features at play here. There's fantastic codecs as part of RDP now that does the compression of the graphic streams, the pixels that are updating, which is pretty much everything right now. And then sending it where it's decompressed on my display. So that's interesting. It proves this OpenGL works. But maybe there's a more interesting test. Now, Microsoft recently acquired a pretty popular game, which is Java-based, which also happens to mean it's actually using OpenGL. So let's try and fire up Minecraft. So remember, this is a Windows 10 Enterprise box using a virtual GPU. If I hit play, it's now launching the application. This is the Windows 10 gaming little dialogue you're seeing there. I have a realm, obviously for my kids, not for myself, and I can hit play. I'll make this bigger. Now you'll notice I'm also getting audio. This is another part of Remote Desktop Protocol. This is not Remote FX specific, it does audio redirection. So this is now me playing the game. I can walk around. This is actually my house in Minecraft. There's the family room. There's my dog. My office. This is all just rendering. I go upstairs. Oh, the dog's barking. It's my pool room. Media room. Older son's room, and there's my older son. It's just a big stone monster. Etc. This is all rendering on the server. I can go wander around. And look how smooth this is. Now, this is not obviously a games technology. This is designed for those AutoCAD applications, those business productivity things. But it's working great. And this really does demonstrate just how flexible this new technology is. I can go and get on the roller coaster I built. Again, just for the benefit of my kids. Whee! All rendering on the server. And look how smooth this is. And this is not with a professional grade graphics card. This is really a consumer GPU that's not really designed for this sort of sharing and virtualizing. But it still works fantastically. So now I have far more flexibility. Now, the requirements on the guest side have always been the enterprise SKU of the client. In this case, Windows 10 Enterprise. Jump off. A big change in Windows Server 2016 Remote FX is it will also now work with Windows Server 2016 guest operating systems. So I can get the benefit of this virtualized GPU in a Windows 10 Enterprise virtual machine and a Windows Server 2016 virtual machine. Disconnect that. So these are great features that really enable me to leverage this technology in a much greater range of ways. So that's totally cool, but there are other improvements as well. Personal session desktops. So this is kind of a mix between VDI and session host. VDI is traditionally a client operating system. Session virtualization is normally a server OS. With personal session desktops, I can essentially enable VDI, but using a server OS as the template instead of a client OS. There's now native pen remoting. So instead of the pen acting like a mouse, it actually natively understands it's a pen interacting with the operating system. Multipoint is now a role of Windows Server 2016. This used to be a separate product. It was used a lot in educational institutions. It really enables a single machine to be connected to from multiple people, they each with their own Windows experience. For example, I could connect 4 keyboards, mice, and monitors to a single machine. Or I could use these little USB 0 devices that connected the keyboard, monitor, and mouse, and then plug those into the machine. Or I could do those over the Ethernet. Or I could use remote desktop. It's a much smaller overhead than a traditional RDS deployment. There's no broker, there's no gateways required. It's meant for these smaller, simpler environments. But now, it's just part of Windows Server 2016. The console. The console's go through some pretty nice new features. And again, this is probably easier just to see it. So if I open up a PowerShell console, so this is PowerShell or it's a regular command prompt. So when I look at my properties, I can see I can use the old legacy mode, or I can use a TrueType font, and I get automatic DPI scaling now. So let's look at an example of this. So if I do my get process, which missing off an S shows me a nice red error, not a new feature. If I do my get process, if I resize this window, it actually modifies the output so it still fits on screen. In the past, I would have just disappeared. Maybe there's something going on in the background, so I'm doing some code, but I still want to see, maybe there's some monitor, see what's happening. I can set a certain level of transparency, so I can see what's going on behind my window as I actually type. For PowerShell, you'll actually notice the color coding. So if I start doing a variable and I want to get my processes, maybe where it's a certain name, it color codes as I'm typing. So I can now see those things. So I get a much richer, nicer environment for both my PowerShell command interface and my CMD. Speaking of which, PowerShell 5, going to be also available in the Windows Management Framework 5.0, continues to build on the fact that PowerShell really is our go-to way to manage Windows, to manage Microsoft solutions, to manage the greater Microsoft partner ecosystem, and even competitors. They have PowerShell modules. This is one technology I can use for interactive sessions, for automation. Very, very powerful. And really with PowerShell 5, it's continuing to refine and I think complete that PowerShell vision. There's a bunch of new commandlets. I can do various string manipulations. There's now a native archive module, so I can do things with zip files. There's new ways to copy between PowerShell sessions, including to Nano, which is going to be useful because there's not really other ways to interact. I can do encryption. I can interact with the clipboard. I can clear recycle bins. I can direct things to the temporary folder. For desired state configuration, I can now throttle how many computers a particular command applies to at any one time. There's IntelliSense when I'm creating these DSCs in the integrated scripting environment. I can run resources under certain credentials. It integrates with popular package managers, which is the big thing right now. So just really continuing this big push for PowerShell to be able to do everything and be even more familiar and friendly to actually work within. So that's my number 9, PowerShell. Number 10, Active Directory. I've always been a big AD fan, and there's a bunch of improvements also around things like federation, new types of authentication, new ways to use LDAP as an authentication source, new ways to customize the view when I access applications. But I want to focus really on just one thing, and that's this privileged identity management. And it's all based around those administrators. You'll notice a theme here. I talked about administrators and shielded VMs, protecting against them. Most organizations, you have a ton of administrators. And it's hard to know, well, who really should be, because you add them and then you forget to remove them. And so you end up with just so many people with so many privileges. And that's very hard to manage and get control of. Really, ideally, you want these processes around it. And this is best understood with a picture. So let's walk through an animation. So here I have your existing domain. And I have a domain admins group with lots of people in it. I have an organizational unit that's been delegated permissions to a group with lots of people in it. So when we use this new technology, I create a brand new Bastion Forest. It's running at Windows Server 2016 Forest functional level, and I enable this brand new privileged identity management feature. I then create a brand new type of transitive Forest trust. So this is where the existing Forest is going to trust my new Bastion Forest. Now there's going to be an update for 2012 R2 that's going to enable this new type of trust. And I'm going to need this because I'm going to do some funny things with SIDs. The SIDs of my identities in my source forest are going to be duplicated and put in tickets that originate from my Bastion Forest. And I have to let them flow over the trust. So I have to modify the way I think about SID filtering. So I create this Bastion Forest, it's trusted. And I create these brand new security principles, MSDS shadow principles, in that Bastion Forest. They have the same SIDs as the principal, in this case groups, as in that source. So my group over here in the Bastion has the same SID, the purple one, as the domain admins group. My delegated group for OU management has the same SID as the other one. Now I can remove pretty much all the users from those source groups. I'll probably leave a domain admin or two around in case there was problems. So now I'm a user, not me because this has hair, but I'm a user and I want some privileges either as a domain admin or maybe delegated over a certain OU. So I go to my machine and I'm going to trigger a workflow. And this workflow is using Microsoft Identity Manager. Do I have to use MIM? No. I could write my own PowerShell to do all the stuff. But the complete solution, and MIM is going to give me these workflows out of the box. So what's going to happen now is it's going to create me an account in that Bastion Forest. It's going to add me to that MSDS Shadow Principal, but it's going to be time limited. So let's say 2 hours. So this is all about the just enough and just in time administration. I'm now going to authenticate against that user over there. When I do that authentication in that Shadow Forest, I'm going to get a resultant token that includes the SID of the principal I need to access resource. But because that group membership was time bound, so is my token. This is a change to the KDC to limit Kerberos ticket lifetimes to that of the lowest time expiring link. So that group membership, that link to the group, has an expiry time. So my ticket will have an expiry time matching that of the lowest ticket lifetime. So I have a ticket. There's a resource I want to access. I access it using that ticket. So this is what you can see here. I went through a workflow. I got the permissions I needed. It's time bound though. Once that time is expired, it kind of self-destructs. My membership, my principal is removed. The membership is removed. My token is invalidated. So now I can't access it anymore. And this is what PIM is giving me. Privileged management, but only for certain times, only for certain resources, and only through workflows. So it removes the scenario where domain admins and other administrative groups just piles up over time. And instead it's a very managed process. It's automatically going to deprovision those as needed. So that was my top 10. And you may have noticed something. There's very much this overarching theme of security. And it really breaks down into two different things. I think about levels of security I get when my HyperV, my fabric, is running 2016. I get a guarded fabric, the shielded virtual machines, protected even from administrator privileges. I have these various virtualization-based security like code integrity, credential guard, these virtual TPMs. I have HyperV Containers, isolation for applications that are kernel mode. Nano-based Hyper-V hosts for super low management, super low attack surface, super low patching requirements, super low reboots. So I get that just by moving my fabric to 2016. But then if I move my operating system instances to 2016 as well, I get even more. Control Flow Guard. This is resiliency to unknown threats. There's these types of attacks that they can change the stack of an OS to list bad addresses to make code go back to somewhere I don't want it to. This is called return-oriented programming. Control Flow stops that. Device Guard. Kernel and user mode code integrity. Make sure the binaries running on the system are blessed by me. Even if malware is put on the system, it won't run. Think of it like App Locker on steroids. I create a box that I think is in a perfect state, and that state is then scraped off to create a policy that I can then apply to other boxes. I can add certain publishers as trusted. Credential Guard. Blocking past the hash other types of attack against my identity. Privileged identity management, just talked about. Just enough administration, just in time administration. I'm not just some blanket admin of everything all the time. I get the privileges I need to do the task I need to do for the time I need to do it. Built-in anti-malware with Windows Defender. Automatic exclusions based on the roles and features I add. All of these benefits I get from Windows Server 2016. And for those that know me and have seen these before, I always have a point one. My point one in this type is Microsoft Azure Stack. This is not WAP v2, and this is not part of Windows Server 2016. I want to be very clear on that. But this is huge. And you might say, well, we had Windows Azure Pack before. Yeah, Windows Azure Pack looked like Azure, but it wasn't Azure. It wasn't consistent with Azure. It's like putting an Arnold Schwarzenegger mask on Danny DeVito. Sure, I look at the face, it looks a bit like him, but he can't do what Arnie can do. Azure Stack is Azure code running on premises. Now, this does not mean every single feature of Azure will make its way to Azure Stack. Some things just won't make sense because of scale, rate of cadence. But for the features that are in Azure Stack, it will be consistent. I will be able to create a template, a JSON template. I can deploy it on premises. I can deploy it to Azure. I can deploy it to that hosting partner that's running Azure Stack. I write my application based on Resource Manager. I can run it on premises to my hosting partner to Azure Stack. I will have a level of flexibility and choice and a hybrid environment that's unheard of until these technologies. I will have complete choice. I can run it on premises and then burst out to my hosting partner, burst out to Azure. I might start off running it on premises and decide to move it to Azure. I won't have to change anything. I'm going to have services like storage, IaaS, networking, all available on premises. PaaS services will be available. And I'm going to expect a far higher rate of cadence than I'm used to for things. This is Azure technology, Azure code. I'm going to take elements of this in a consistent way, bring this on premises as well. Now, this is not running on top of System Center. Again, this is its own product. But certainly, I can still help manage those guest environments, other elements of my infrastructure with System Center, as can things like the Operational Management Suite. So I think of Azure Stack as building on so much of the yummy goodness we get in 2016. HyperV, Nano Server, network virtualization, storage spaces direct, to name just a few. Azure Stack's going to build on that to give me that consistent Azure experience. So I hope this was useful. I hope this helped see some of the benefit of Windows Server 2016. Again, I'm going to start doing a lot more of these Ask Me Anything. So please go join the Twitter so I can announce when I do these things. But I really appreciate the time and thank you.